So we're going to talk about average rate of change today. So average rate of change is basically just how quickly one variable is changing compared to another. You were actually doing this all the way back in grade 9 and maybe didn't realize it because it's just the slope of a line. So if I want to know the average rate of change between 2 points, that's really just asking me to find the slope. Now, we're probably used to doing y2 minus y1 over x2 minus x1, but because we're a bit more grown up, we are going to use f at b minus f at a all over b minus a. Keep in mind that that's exactly the same thing. You're welcome to use the old formula for a little bit, but you really should get used to this new one, especially if you plan on taking calculus. So instead of saying that x is between a and b, we learned interval notation. We can use square brackets saying x is between a and b in this way. So if you're calculating the average rate of change, we shorten that to AROC, and it's just about finding the slope. The hardest part of this kind of question, I would say, is finding the units. So rate of change always needs the word per, PER, as part of the units. So for example, kilometers per hour is a possible unit for rates of change. Meters per second, just centimeters though, that's a distance. It's not a rate of change. So this is not a possible one. Speeds are more intuitive to students, but you could also have something like degrees Celsius per hour. Maybe your oven is heating up and you want to know the rate of change of that. Or people entering a mall, so you want to talk about how many people per minute are entering. So just be careful about the units for that. A line between 2 points, by the way, is called a secant. So this is about finding the slope of a secant. Okay, our first question, we're given an equation and you want to find the average rate of change between 1 and 3. One thing to note is communication-wise, we're not going to say f for the function because the function has a name. The function is s. You never want to call the function a function by the wrong name because that's just rude. So again, s at b minus s at a over b minus a. Our a and our b values are here. Remember, this is just y2 minus y1 over x2 minus x1. We sub those in. You can do that to the side if you want. Please don't forget brackets. And we get 7. Now, actually interpreting this is the tricky part. So first of all, we want to say on average, this is the speed, because that doesn't mean that this particle's traveling 7 miles per or meters per second the entire time. It's just on average. It would be like saying we traveled 100 kilometers per hour on average during our drive to Montreal. It doesn't mean that you're driving that speed the whole time. It just means that sometimes you were driving slower and sometimes you were driving faster. I would also like you to interpret this. Sometimes it's not going to have an interpretation. You know, people per minute doesn't have a contextual interpretation. But something like meters per second we know is referring to speed. So I want you to use the word average, ideally use the word speed, and the units are the most important part. You can figure out the units by thinking, okay, S is measured in meters because it says S meters, and these are measured in seconds because T is in seconds. And you have your units right there, meters over seconds, so meters per second. I also want you to say what interval it is. So again, it doesn't mean that it's traveling 7 meters per second on average the whole time. We just calculated it for these few seconds. So please state that. Okay, so again, we're calling the function the same thing. We're calling it P instead of F. This got misaligned, I think. And then the interval is from 2 to 5. Remember, you're just replacing the t with 5 and the t with 2. Another communication mistake that happens sometimes is students won't make your division sign long enough. So just make sure that it covers everything that you want it to. And be mindful of putting this into your calculator. Don't forget that you're subtracting this whole thing and dividing this whole thing by 3. So again, for the context, we want to say average. And here, the number of people is increasing by 43 people per hour. So we need the units and we need the time as well. I got 10 a.m. and 1 p.m. because this was hours since 8. So 8 a.m. plus 2 hours gave us 10 a.m. and 8 a.m. plus 5 hours. That one gave us 1 p.m. Okay, this one's a bit of a tricky question. So I started by writing the actual equation for A rock that we have above. H equals B minus A. We can rearrange that so that we have B equals A plus H. We also know that we had B minus A in the denominator, so we can actually just change that to H. We can also change the B to A minus H because that's what we rearranged it to be. So we have this new formula, F at A plus H minus F at A all over H. It seems really arbitrary, but actually this is what you're going to be using in calculus to find the derivative. Now, what does H actually mean here? So A and B were our X values. And if H is B minus A, you can see that it's actually the distance between these two. So H is the horizontal distance between the 2 points that we're talking about. And again, this will come back more in calculus. Thanks for watching.